Good day, students. Welcome to part two of the January 2010 New York Regents um, exam for Mathematics B. In this part, the second part of the series, we're going to be working on questions 11 to 20 um, of the release questions. Okay, if you want to view part one of this video series, you can click down here, and that will take you to the first part. All right, let's go ahead and move on to question 11. It says, if measure of angle A is 40 degrees and side A and is 5 and side B is 6, how many different triangles can be constructed? Now, the ambiguity comes here when you're dealing with inverse sign. Whenever you take the inverse sign, you get two possible values that could work for your solution. What are the two possible values? That lies in the fact that when you have your coordinate system like this, um, you know that sine, you have all students take calculus. All students take calculus. You know that sine is positive in the first quadrant and in the second quadrant. So whenever you take the, let's say you solve an equation, you have the equation sine theta equals a, and you want to look for what theta is. When you take the inverse sine of both sides, there are two possible values that can satisfy this equation. Because a is positive, that means the angle can be in the first or second quadrant. So if this cancels out, that cancels out. You have theta equals inverse sine of a. All right, so what are the two thetas that satisfy this equation? The first, remember, theta is just reference angle. So the first angle is going to be in the first quadrant like that. So the first angle that satisfies the result is this angle right here. So you test it in your triangle to see if the sum of angles equals 180 to see if that works. And then the first quadrant normally works. The one that normally fails is the second quadrant right here. It could work or it could fail, you never know. So the second theta, now the reference angle, I'm going to call this theta reference. It's not the actual angle. All right, so when you're applying it to quadrant 2, the actual angle is what you get when you go from here all the way there. So theta in this case is simply going to be, theta is going to be 180 minus theta reference, okay? So the first answer you get, the first theta you get here, that's a good answer. The second one, just subtract 180 from that and test it, okay? What you need to remember is that the sum of angles in a triangle is always equal to 180. Okay, so anytime you add two angles, so measure of angle A plus measure of angle B must be less than 180 because you need something for angle C, right? Measure of angle A plus measure of angle C must be less than 180 because you need something for angle B. And then measure of angle B plus measure of angle C has to be less than 180, all right? Because you need something for angle A. If you add any two angles and it's bigger than 180, then that means you can't have a triangle because the last angle can't have any value. All right, so keep this in mind. This is the triangle angle sum theorem. All right. So now let's go ahead and solve this problem. To solve this problem, I'm going to make myself a triangle. Nothing special. And then we're going to try and name it in a method that's consistent with the standard lettering systems when you're working with law of signs. All right, so there you have a triangle. Let's call this angle A. If this is angle A, the side opposite it will be little a. All right, and if this is angle B, then the side opposite will be little b. And if this is angle C, side opposite it will be little c. All right, now measure of angle A is 40 degrees, so this is 40 degrees, and side A is 5. Measure of angle B, I don't know, but I know side B is 6. So I can just focus my attention on angle A and angle B when I'm testing my triangle angle sum theorem, right? So if we find angle B, we're going to try and see if we can create two triangles or just one triangle, all right? So how do I find angle B? We use the law of sines. If you look at your reference sheet, you have the law of sines there. So to find angle B, I like to start with what I'm looking for. I'm going to say sine, well, let's just say sine A over little a is equal to sine B over little b. Okay? This is the law of sines. And I'm going to plug in the values I know. So I'm going to have sine 40 degrees over little a, which is 5, equals sine b over little b, which is 6. Okay? Now, to get sine b by itself, I multiply both sides by, wait a minute, let's see. It's 5 b 6, good. I multiply both sides by 6, so I times this side by 6 here, times this one by 6, times this by 6. This cancels out, and then I'll have sine b equals 6 sine 40 over 5. All right. Okay, let's plug that in the calculator. 6 sine 40 over 5. All right, so if you plug that in your calculator, you're going to have sine b equals 0.77134 to 5 decimal places. Now we're going to take the inverse sine of both sides. So inverse sine of sine b on the right side equals inverse sine of 0.77134. So now this is where you're going to have the ambiguity, because b is equal to 50.74 degrees. Now this could be your this angle right here is two things. Okay, this angle measure that we're having right here, this could be your actual theta. One possible measure of b, this could be theta, and it's also your theta reference. Okay, so there are going to be two possible values for b that satisfies this equation that we did right here. So the first value is what you got, 50.74, and the second value of b is what you get when you subtract 180 minus 50.74. Okay, so you can work that out. All right, so you can work that out. I just switched something around. Okay, let me fix something. This is supposed to be 47, not 74. So 50.47. Sorry about that. I tend to switch numbers around in my head. So, all right, so it's 50.47. Now, so 50.47 is your is an answer for B, and also is also the reference angle. So the second answer for B you can get is what you get when you subtract 180. Subtract 50.74 from 180. If you subtract that, you get 129.53. Okay, degrees. So let me just show you the geometric significance of what I just did. So I told you whenever you take the inverse sign, there are two possible answers. One is in the first quadrant, the second is in the second quadrant, because we know that sign is positive in both. All right, so the first A value that we got, the first B value that we got is 50.74, okay, 0.47. The second one is the second possible value is what you get when you use 50.747 as your reference angle. All right, so the second value of A that could possibly work is this measure right here. And all you do is you just go 180 minus 50.47, and then the answer you get is 129.53. Okay, so now that we have our two candidates, which of these makes it possible to formulate a triangle? I know angle A is 40 degrees. So if I add these two to this angle, if I get an angle that's less than 180, then I'm good. But if it's bigger than 180, then that answer doesn't work. All right, so let's test the first one. Um, Let me call this triangle 1. All right, and then this one is for triangle 2. We don't know which one is going to work, so let's test triangle 1. So if I'm testing triangle 1, the question is angle A plus B less than 180? That's the question. All right, is measure of angle A plus measure of angle B Is it less than 180? If it is, that means we still have something for C, which is good. So is 40 plus 50.47. Is it less than 180? Is it? If you add it, you get 90.47. And this is less than 180. Excellent. So you can have a triangle with this measure, and then angle C is going to be like 89 point something. All right, so that's good. All right, now let's test triangle 2 to see if this combination of angles work. So the question is, same question is measure of angle A plus measure of angle second B. Is it less than 180? Angle A is 40. If I add 50, oh wait, if I add the second measure, which is 129.53, what do I get? I get 169.53. And that's less than 180. That's excellent because we still have some measures for um, angle C. If it were 180 or bigger, then that will fail. Okay? So guess what? How many triangles do we have? We have two triangles. Okay? So that one is option number 2 for number 11. All right, let's move on to question 12. This is a pretty interesting problem. Let's move on to question 12. It says, which is the equation of the axis of symmetry? In the equation, y equals x squared minus x squared minus 3x minus 6. So you just need to remember the equation of the axis of symmetry is x equals negative b over 2a. Okay, remember this is like a as a parabola, right? So if you graph your parabola, um, a parabola has a vertex. So if this is my parabola right here, oh, that's a terrible one. Let me draw it again. So you have a parabola like this. Okay, you always have a vertex, and the coordinate of the vertex is negative b over 2a, comma f of negative b over 2a. Okay, so that's always the coordinate of your vertex. Okay, so the vertex contains two values. Depending on the orientation, I'll write that again, negative b over 2a. Depending on your orientation, it could be your max or the mean. In this case, it's a mean. If it's a downward facing, it would be a max, and that's the y component. So the x component tells you the axis of symmetry. Axis of symmetry. And guess what? The y component tells you the value of the max or the mean. Okay? In this case, we just need the axis of symmetry. So all we just pick is just the x, because if I focus on just the x and I have that assume all the values, then this line right here, this x line right here, that will be the equation of the axis of symmetry. So the equation of this line right here is x equals negative b over 2a. All right, so you just have to remember that. So let's do that. In this problem, b is the coefficient of x squared, which is 1. No, wait, that's a. Sorry. So a is 1. Um, a is 1, b is negative 3, and then c is negative 6. So we're going to plug all that into this equation. So you're going to have negative 3 over 2 times a, which is just 1. Okay? So we're going to have 3 over 2, and that's the value of your um, axis of symmetry. Remember, it's x, not y. The y is the max for the mean, okay? So your answer is option 2. All right. Now let's move on. Number 13, it says, what is the range of a set of data? Remember, range is the vertical, let's say range is the vertical spread, okay? And then your domain is your horizontal spread, okay? Horizontal spread. Now, when you're doing a vertical spread, you're going up and down, right? Horizontal spread, you're going side to side. If you're going up and down, what measures are you using? You're using your y, right? And then the domain, if you're going vertical spread, you're going along your x-axis, right? Okay, so let's take a look at this graph. To find the range, I'm looking at what is the vertical span or spread of this graph. This is the high point, and this right here is a low point. So the inequality that gives me the range or the spread from this value to this value is my range. All right, so the lower range is around 56, and the upper range is around 70. And y assumes any value between these two. So we're going to have 56. Since you have a closed circle right here, it's going to be less than or equal to y. Remember, we're going up and down along your y-axis. Less than or equal to 70. That's your range. Okay? So this is the range. Answer is option, wait a minute, gotta be careful here. Option 4. Some people pick this and mess up the problem, but that's wrong. Okay, so there you have it. Next question. Question 14, which expression is equivalent to this? Um, this is a complex number in an unsimplified form. So we need to simplify it. To simplify this, we need to multiply by the complex conjugate, all right? The complex conjugate is what you get when you take the opposite of the imaginary part. So I'm going to multiply this by 2 plus I on the top over 2 plus I on the bottom. All I do is you take the opposite of just the imaginary part, all right? And then we're going to multiply it across by distributing. On the top, we simply 2 plus I. And on the bottom, we're going to work out 2 minus I times 2 plus I. We just FOIL it out, or you double distribute, whichever one you like. So 2 plus I. If I'm doing the bottom, 2 times 2 is 4. 2 times I is 2I. I times I is negative 2I. And then I times negative 1 is negative I squared. Remember, I came about by when we're looking for the value to satisfy the equation x squared equals negative 1, right? So let me simplify this a little bit more. So I'm going to have 4. The middle terms cancel out since they're opposites, minus I squared. So remember that the square root of negative 1, they came up with this letter I as a solution. So that tells me that I squared is what? Negative 1. So don't forget this fact. I squared is negative 1 when you're dealing with complex numbers. So this becomes 2 plus I over 4 minus negative 1. And then you have 2 plus I over 5. I'm sorry, 4 plus 1, which is still 5. I skipped a step. And then which is 2 plus I over 5. Okay? So your answer is 3. Option 3 is your answer. All right, let's move on to question number 15. It says, find f composed with g if f is 2x minus 1 and g is 3x plus 1 plus 5. So you got to remember whenever you have that little circle there, that circle means to compose, all right? Compose basically means you plug the second function into the first one. So f composed with g of x is simply f, because this is the first one, and then the second one goes into the first one. Whatever x is for the first one, that's what g becomes. So that's what that is. All right, plug in this business, substitute it for the x in g, in f. Okay, that's what we're going to do right now. All right, so to get everything organized, what I'll do is I'll start with the function, the original function, which is f of x. All right, and then that is 2x minus 1. And I'm going to be plugging in g into that. So I need to clear out my x's in preparation for the input function, which is g. The value, the name of my input function, g, goes here, and the value goes to the right. Okay, so I know g of x is 3x plus 5. This is the name of the function. It's going to go right here, okay? And then the value of the function, which is 3x plus 5, is going to go right here. All right, so let's do that. So the name is g of x, and the value of g of x is 3x plus 5. All right, this is basically what f circle g means. Okay, f of g of x. All right, let me just put it here so you can get the gist. This is f circle g. It's not fog, okay? Some people call it fog, I don't know why. Anyway, so you have that. If you simplify this, you have 6x plus 10, a consequence of distributing 2 to these two numbers right here, minus 1. And then your final answer is 6x plus 9. All right, so answer to number 15 is that. Remember, F circle G is not the same thing as F times G. They're two entirely different things. If you multiply, you probably get this answer, which is wrong. All right, so keep that in mind. They're different. So don't do this. Just compose. Okay, let's move on to question 16. It says, which is the equation of the graph, of the accompanying graph? You can plug this into your calculator. You easily see what that is, a logarithmic function. So it's either this or this. Exponential functions are the inverse of that. They go like this. This is exponential. Logarithmic go in this direction. Okay, so this is log, and this is exponential, a to the x. Okay, so which of these satisfy this equation? We know that I could either use this point, or I could use this point, or I could use that point. This point is useless to me because I know that regardless of the base, uh, log base a of 1 is always going to be 0. So regardless of what the base is, this is base 10, this is base 2, this is always going to be 0. So this point here is useless. So I got to pick a point that is unique to the situation. Okay, so I can use this point right here to do my test. I'm going to do a test. Okay, so this is the deal. This value here is 2, and this value here is 1. So if I plug in 2 for any of these, which one will give me 1? Let's try option 1. I have y equals log. This is base 10, right? If you don't have any numbers base 10 of 2, what is this equal to? It's not. It's obviously it's not equal to 1, is it? Well, let's try. This option doesn't work. Let's try the second one. So this is option 3. Let's try option 4. Y equals log base 2 of 2. So this is 2 to the 1. Remember the logarithmic rule? If you have log base a of a to the x, these two cancel out. The answer is x, right? So if this, see what happens here? These two are the same. Since they match, they cancel out, and your final answer is just simply 1. Okay? So you can clearly see that this is the answer. If you're not convinced, you can test that point right there. Log base 4. You can do that. So y, so this is 4, and the output is 2. If I wanted to test that one, log base 2 of 4, is it equal to 2? If I simplify this becomes log base 2 of 2 squared. These 2 cancels out, and y equals 4. I mean, y equals 2. That's exactly what we want to check. Because when x is 4, y is 2. So these two equations shows me that option 4 is your answer. All right, let's move on to 17. It says which quadratic equation has roots 2 minus 3 and 2 plus root 3? So there are two ways of doing this. For this one, you could do the quadratic formula 4 times and see which one gives you this as a solution, or you can distribute this out. Okay, I'm gonna do the latter method I mentioned. I know that my answers is x are x equals 2 minus root 3 and x equals 2 plus root 3. Uh, so that's, these are my roots. That basically tells me I could make these two equal to 0, so I could subtract 2 and add root 3. On this side and this side, subtract 2 and add root 3. So I'm going to have x minus 2 plus root 3 equals 0. And then this one I could do the same, subtract 2, subtract root 3 from both sides. And then I also have x minus 2 minus root 3 equals 0. All right, so if I, so since this is 0 and this is 0, I can write down the expression x minus 2 plus root 3 times x minus 2 minus root 3 equals 0. All right. So now if I distribute this two roots, in fact, with form, I should get one of this. All right. So this is multiplying it 3 by 3. So it's important for us to organize it carefully so we don't get ourselves confused. All right. So I'm going to go x minus 2 plus root 3, and then x minus 2 minus root 3. Now this is the deal. Whenever I'm multiplying terms with more than 2 terms, I like to use the vertical multiplication method so I can stay organized while multiplying, all right? If it's just two terms, I could just multiply horizontally, but this one I'm going to multiply vertically so that you see how I organize everything. I'm going to make sure that like terms or like degrees stay in the same column, all right? So let's start out with root 3. Negative root 3 times root 3 is root 9, negative root 9, which is just negative 3, okay? And then negative root 3 times negative 2 uh, is going to be 2 root 3. So positive 2 root 3. So I'm going to put 2 root 3 over here. And then negative root 3 times x is going to be negative x root 3. Let me put that over here. This is positive. So negative uh, x root 3. That's multiplying this by this. All right, now let's do the 2. Negative 2 times root 3 is negative 2 root 3. That's similar to this. So negative 2 root 3. And negative 2 times negative 2 is positive 4. There goes number over here. Negative 2 times x is negative 2x. Let me put that way over here. Negative 2x. Okay? And then x times root 3 is x root 3. Oh, that matches with this. X root 3. X times negative 2 is negative 2x. That matches with this. This is a plus. And then x times x is x squared. Put that over here. Okay? You see how I organize it? X squared is here, x is here, x root 3 here, 2 root 3, and then the numbers go in the last spot. All right, now I'm going to add downwards, and that should give me my final answer. So adding downwards, I'm going to have x squared. These two combine to negative 4x. These two are opposites, so they cancel out. These two are opposites also, so they cancel out. When I add those two, I'll get plus 1. And that goes my final answer. And that's option number 3. Okay. Now, if this method is too complicated for you, you can just use x equals negative b plus or minus the square root of b squared minus 4ac over 2a. You can do this carefully, do it on each problem, and then one of if you do it on this problem, you're gonna get these answers right here. All right, so I use the reverse method. Whichever method you like, that's fine. Okay. All right, let's move on to the next question, question number 18. It says, what is the solution set of root 4x plus 21 equals x? Now, one thing you have to note here is whenever you're dealing with radical equations of this nature, uh, extraneous solutions might be introduced. Okay, so whenever you do this, solve problems of this nature, you always want to do a check to make sure that all your answers are valid. Sometimes you have no solution, sometimes you have one, sometimes the two answers you get are valid. So you can see here, we have either one solution, option 1 or 3. Both solutions are good, which is option 2, or there's no solution. We have a reason for giving all these options because everything is likely possible. All right, so when dealing with equations of this nature, you always have to check. So always do a check. Okay? It's good practice. Um, if I wanted to be lazy, I can just plug these answers in and see what works, right? And that would be a quick way of doing it. But I want to show you the whole mathematics, the long way of doing it. Okay? So let's see. I want to get rid of the square root. So the opposite of square root is square. So I'll square both sides. You square this side and square that side. Square and square roots cancel out. On the left side, you're going to have 4x plus 21 equals x squared. I want to write this as a quadratic equation. Quadratic equation in standard form has to be equal to 0. So I'm going to move these terms to the right, subtract 4x, subtract 21, and then subtract 4x, subtract 21. That will put my quadratic equation in standard form. So I'm going to have x squared minus 4x minus 21 equals 0. So to factor this, I'm going to use the X factor method. You can use guess and check, the box method, the asterisk method, anyone that makes you happy. But I like to use this method. So I'm going to put AC on the top, which is negative 21. This is A. A is 1 because there's no number there. This is B, and this is C. AC goes on the top, B goes on the bottom. B is negative 4. So ask myself, what two numbers times to give me negative 21 and add to give me negative 4? You can try 7 and 3. Since this is negative, I'll make the bigger number negative, like that. Okay? So That should do the trick. So I'm going to plug in these two numbers here. I'm going to have x squared minus 7x plus 3x minus 21 equals 0. I'll break it down to center and factor by grouping. From the first two, I'll factor out x. And I'll be left with x minus 7. And then I take out 3 from here, times x minus 7. What I'm doing here is a little bit complicated. I have a 3 video series on factoring quadratic trinomials. If you go over those tutorials, it'll really help you to master how to factor any factorable quadratic trinomial. Okay, so these two are the same, so I'll factor it out. I'll have x minus 7. And then when I factor that out, I'll be left with x plus 3. So I have x plus 3 here. That equals 0. Now I'm going to use a zero product property, the opposite of what I did in the previous problem. And I'll set each factor equal to 0 because your product is 0. Okay. Now to solve this, I'll add 7 and add 7. I have x equals 7 for this. And then I'll minus 3 minus 3, and I have x equals negative 3 for that. Alright, so are these my answers? I don't know yet. I have to do a check. Remember, you always have to do a check. Because when we squared it here, when we did the squaring here, we might have introduced some extraneous solutions. Okay, so that's why it's imperative that we do a check when you solve absolute value equations. So the first one I'm going to check is x equals 7. All right, so I'm going to plug it into the original problem. I'm going to plug it into, well, let me write down the original problem. So the original problem is square root of 4x plus 21 equals x. All right, so if I want to test this one first. So for that one, the question is the square root of 4 times